Good morning, students. Today we are going to see Chapter 4, Algorithmic Strategies. An algorithm is a strategy that always guarantees in the correct answer. A strategy might yield incorrect results, but a correct algorithm will always produce correct results. Learning objectives. After studying this chapter, you will be able to understand how to write an algorithm, how to analysis of an algorithm, and what are the complexities of an algorithm. Writing an algorithm. Algorithms are generic, which means it does not limit to computer alone. It can be used in various real-time activities. If we perform many algorithms already knowingly or unknowingly in our daily life, such as packing books in a school bag, finding shortest path to search a place, scheduling day-to-day activities, preparation for examination. As we know that all programming languages share basic code constructs like conditions and iterations which can be used to write an algorithm. In our day-to-day life, we need to take various decisions and choose an alternate path to achieve our goal. Maybe we would have taken an alternate route to reach our destination when we find the usual road by which we travel is blocked. Here, this type of decision making, what we learn to through the conditional statements. Here the computer system, which is made up of three main parts: input, process, output. Here the input, which is given by the user and process the input by the machine, and it produces the desired result, that is the output. Here the data is nothing but raw fact. Information means collection of data. Let me see example of algorithm as copy preparation. Water, coffee powder, sugar. Here, these ingredients are the inputs of an algorithm. Here, preparing a cup of coffee is called process. The output of this process is coffee. The output of this process is coffee. Let us see the procedure for preparing coffee. Step 1. Take a bowl with coffee powder. Step 2. Boil the water and pour it into the bowl. Step 3. Filter it. Step 4. Boil the milk. Step 5. Mix sugar and filtered coffee along with boiled milk. Step 6. Pour the coffee into the cup to serve. Here this kind of procedure which can be represented using an algorithm. Here this algorithm which consists of step-by-step instructions which is required to accomplish a task, and it's helped the programmer to develop the program. Let us see design an algorithm to find the square of the given number and display the result. Here the step 1 is start the process. Step 2, get the input x. Step 3, calculate the square by multiplying the input values, that is square x multiply with x. Step 4, display the result square. Step 5, stop. Here a algorithm which could be designed to get a solution of a given problem, a problem which can be solved in many ways. Among the many algorithms, here some algorithms are optimistic, which one can be taken for implementation. If an algorithm that is expected output for a valid input is called an algorithmic solution. Let me see analysis of an algorithm. Here computer resources are limited. Here efficiency can be defined by the utilization of time and space complexity. Here this algorithm, which can be analyzed by deals with the running and execution time of various operations involved. Here the running time of an operation, which is calculated as how many programming instructions executed per operation. Here the running time of an operation is calculated number of programming instructions executed per operation. Here the analysis of an algorithm, which can be divided into two different phases, a posteriori testing, a priori estimates. A priori estimates, here something that can be known without experience. Here this is a theoretical performance. This is a theoretical analysis of an algorithm. Here the efficiency can be calculated by measuring the external factors. For example, 5 is a prime number, brothers or male siblings, 3 plus 3 is equal to 6. Here x is a red, x which has a color. A posteriori testing is nothing but can only be known with sense experience. Here in this analysis, actual statistics like running time and which is required for the algorithmic executions are also collected. For example, it often rains in Portland. My dogs like chicken. Algorithmic complexity, which is a measure for evaluates the order of the operations and also it's performed by the given algorithm. Algorithm as the function of the size of the input data. Here algorithmic complexity means it's an approximation of the number of steps necessary to execute an algorithm. Here just depend on size of the input data. The time and space used by the algorithm by defining the two factors, that is time factor and space factor. Here the time factor is nothing but measuring the number of key operations, that means like comparisons in the sorting algorithm, which makes the algorithm such a order. Space factor, which is measured by the maximum memory space which required by the algorithm. Here just referred as the allocation of spaces in the memory. Here the time complexity of an algorithm, which means the total time required by an time complexity of an algorithm, which means the total time required by the program to run till its completion. Space complexity is a measure of the amount of working storage of an algorithm needs, which means how much memory in the worst case is needed at any point in the algorithm. Here the complexity, we are mostly concerned with how the space needs to grow and how to solve this problem by using the minimized space in the allocation. Here the space complexity of an algorithm, which is the amount of memory required to its completion. Here this space required of an algorithm, which is equal to the sum of the two components. First one is fixed part and second one is variable part. Fixed part, a fixed part which is defined as the total space which is required to store certain data and variables for an algorithm. Here the examples are simple variables and constants which we are used in the algorithm. Variable part, here a variable part which is defined as the total space required by the variables. Here this size, it depends upon the problem and it makes some iterations. Here the example is recursion, which is used to calculate the factorial of a given value n. Review on book. Let us see how to write an algorithm. Here the algorithms are generic, which is nothing but it's not limited to computer alone. It can be used in various real-time activities. Hereby we are knowing or unknowingly we perform many algorithms in our daily life, such as packing books in a school bag, finding shortest paths to search a place, scheduling day-to-day activities, prepare for examination. Here these are the basic programming languages which we are going to construct some conditions and iterations. Here the conditions which is based on a decision making. If a typical algorithm, it accepts input which is given by the user and it processes the input which produces the desired output. Let us see the example for the coffee preparation. If we want to make a coffee, we need to have the certain ingredients: water, milk, coffee powder and sugar. Here these ingredients are the inputs of an algorithm. By preparing a cup of coffee is called process. Here the output is coffee. Here given some procedures. First one is to take a bowl with coffee powder and boil the water and pour the coffee powder into the bowl and filter it, then boil the milk, then mix sugar and filtered coffee along with boiled milk, and finally pour the coffee into the cup, then to serve. Here these are the procedures which can be represented by using an algorithm. Here this algorithm, which consists of step-by-step instructions that which are required to accomplish a task. And let me see the another example to find the square of the given number. Here start the process. Step 2, get the input x. 3, calculate the square by multiplying the input value, that is x cross x. And finally display the result square and stop the process. Let me see what is the difference between an algorithm and program. Here the algorithm, it helps to solve a given problem logically, but it contrasts with the program. Here the program is an expression of an algorithm in a programming language. Here the algorithm which can be categorized based on their implementation methods, that is, design techniques. But the algorithm can be implemented by structured, which is procedural or object-oriented programming approach. Here, algorithm, there is no specific rules for writing, but a program it should be written for the selected language with specified syntax, whether it's C, C++, Cobalt, etc. Algorithm, it resembles a pseudocode which we can be implemented in any language, but a program which is more specific to a specific programming language. Analysis of an algorithm. Here, an efficiency of an algorithm which is defined by the utilization of time and space complexity. Here, an analysis which deals with the running and execution time of various operations and also allocation of memory. Here, this running time of an operation, which is calculated as how many instructions executed per operation. Here, this analysis, which can be divided into two phases. First one is priori estimates and second one is posteriori testing. Here, the priori estimates, which is the theoretical performance, that means something which can be known without experience. But a posteriori testing, this is the performance measurements, that means which we can only be known with sense experience. Complexity of an algorithm. Here, the complexity of an algorithm which can be calculated by the two factors, time factor and space factor. Here, the time factor is nothing but measured by counting the number of key operations like comparisons in the sorting algorithm. Here, the space factor is nothing but is the maximum memory space which is required by the algorithm. Here, this time complexity of an algorithm which we given by the number of steps which taken by the algorithm to complete the process. Space complexity of an algorithm, which is the amount of memory space required to run to its completion. Here, the space complexity, here the space which is required by an algorithm is equal to the sum of the following components like fixed part and variable part. Here, the fixed part is nothing but it stores certain data for fixed, which we cannot be changed. But a variable part which can be changed. Here, the total space required by the variables. Here, the sizes, it depends upon the problem and its iteration. In the examination point of view, here these are the questions which will ask in the examination. First one is discuss about algorithmic complexity and its types. And second one is what are the factors that influence time and space complexity. Here these both questions which were asked in the 3 marks. I hope you all understand this session. We learned this session how to write an algorithm, how to analyze an algorithm, and what are the complexity of an algorithm. Let me discuss the next session. What are the efficiency of an algorithm and how to calculate the efficiency. Thank you, students.